Let's talk for just a little bit. This is an introduction. We will revisit the squeeze theorem. But I want to give you the idea in the context of limits that we have another tool in our tool chest for evaluating limits. So we're going to set this up. Let the function f, g, and h be functions that satisfy this relationship. In the plane, for us visual learners, what this says is that all of the outputs on the function f lie in the plane, and I'll just put f right here, lie in the plane everywhere below or equal to g. So I'm going to say g is, we'll say g is that function. There's g. Now f and g share that point, whatever that point is. Let's call that point C. This also says, this relationship says that all of the outputs on G lie everywhere in the plane below H. Now they may share a point or two, but G lies everywhere in the plane below H. So I'm going to call that H. Now F and G and H share the same output value. We'll call it that value right there. We'll call it L. They all share the output value at x equals C. So if I'm looking at what's happening as I approach C from the left and as I approach C from the right, on the function g, I can clearly see by what I have drawn here that that output is L. Well, let's say I don't have the graph. I don't know what's going on G. But I do know that this relationship exists between F and G and H. If I determine analytically that as I approach input values of C on the function f, which lies everywhere in the plane below G, and as I approach the same input value C on the function h, which lies everywhere in the plane above G, now they may share a point or two, if I can determine that those two limits exist and that they both equal the same value, then this relationship, I have to have this. This is the if. If this exists and G lies everywhere in the plane between F and H, then I know that as I approach input values on G, the output values must also approach L, because G is squeezed in between F and H, and at input values, the output values have to be approaching the same value. This is an if-then statement. I don't get this unless I had this to start with. This is part of the if statement. If the relationship between F and G and H is given as such, and the function below and the function above near some input value approach the same output, then the function in the middle near that same input value must approach the same output value. There's the squeeze theorem in the context of limits. We'll see the squeeze theorem in the context of other calculus techniques as well. So verbally we would say let f, g, and h be functions where the value of g lies between the values of f and h. If the limit of f is equal to the limit of h, we'll call it L, then the limit of g also has to be L. So make sure that you could apply or talk about most specifically the if and the then part of the squeeze theorem.